In this video, we are going to build an instant music recommendation system where the user can select a song and click on recommend similar songs, and we are going to recommend top 5 songs based on their selection, and we are going to give the details of the artist and the song that may like. So this is what we are going to build in today's video. Hello everyone, I am Siddharthan and we are going to build a content based music recommendation system and build a user interface in Streamlit where the user can select a song of their choice and we can give them top suggestions on like what they may like based on the song that they have heard before. So this will be the agenda, and for building this entire end-to-end application, right, first we will try to identify the data set using which we can do this and the base code in order to process this data and how to build this recommendation system, and then how we can convert it into a Streamlit user interface or a Streamlit application in Python. So these are the individual topics that we will discuss today, and let's get started. So for the dataset, we will be using this Kaggle dataset called as Spotify million song dataset. So I'll give the link of this dataset file in the collab notebook that we are going to work on. So you can just like refer to this and we can work on this dataset in order to build this recommendation system. And as per the coding part, we'll be doing this on Google Collaboratory, or you can also do this in Jupyter Notebook as well. So I'll share this particular notebook with you that you can refer. And in this, I've given this dataset link, which is going to take you to this Spotify million song dataset. And make sure that you have an account on Kaggle because we are going to need the Kaggle API key to connect and download this dataset. So we come back here. The first step that we do is like make sure the system is connected. So you can just like create a new notebook and connect it. You don't need a GPU, as like we are not using any models per se, but this is more of like finding similar songs based on content. So we don't need any models to train. So a CPU instance itself is fine. So the next step is like we need to install this Kaggle library. So you can just do pip install Kaggle with this exclamatory mark that says this is a command, and I'm running this on quiet mode so that it doesn't, you know, clutter the output with a lot of text and so on. So it's going to download that. So once this is done, we are importing the dependencies. So for this, like we need OS, JSON, zip file, and so on. So OS is to access the environment variables, JSON is to access the JSON file, which is the Kaggle API key that we would get, and zip file is used in order to extract the zip file that we get from Kaggle, NumPy and pandas for data operation and manipulating the data in a data frame. Matplotlib is if we want to make any plots, we need that. And TF-IDF vectorizer is like we have to convert this word into meaningful numbers that the computer is going to understand. So we are going to use a vectorizer for that. And a cosine similarity, which is the key part here, which is used to find a similar song. So it gives a score, a similarity score for each of the songs so that we can recommend the similar songs to the user. So that for that we are using this sklearn metrics pairwise cosine similarity, and word cloud is kind of a plot that helps us understand how the words are present in this entire data set. And RE, the regular expression, is like used to kind of find some patterns and match it. NLTK is the natural language toolkit, which has some NLP tools that we need. So we are going to use the tokenizers and we are going to kind of remove the stopwatch from this. So we have like all these things. And finally, we have word tokenize, which is going to tokenize your lyrics into like individual words. So these are the dependencies that we need. So all these libraries are like kind of pre-installed in Google Collaboratory. So if you are running this on your local, on a Jupyter notebook or a different environment, so you have to like download all these libraries separately. So let's say that we are done with importing the dependencies. The next part is like data collection. There are two ways to do this. One is you can open your Kaggle, this Spotify million song dataset. So you can just like click the CSV file. This Spotify million song data.csv is what we have. So it's a 74 MB dataset file. So you can either download this from here and then upload it from your files, but that may take some time. So rather what we are going to do is use a API, Kaggle API, and import this data directly. So for that you're going to need this kaggle.json. So that would be present in your Kaggle account. So if there are any permissions, right, this is again, if you are joining some competition in Kaggle, you have to first accept that permission and accept the conditions of the competition, and then you have to download this kaggle.json, which is your API token. So once like everything is done, in this case, like I don't think this is a competition and I don't think this would require that, but in general that's what you have to do. So let's say that you have an account in Kaggle, and make sure that your account is verified with phone number and email address and all those things. So then only your API is going to work. So if you don't do that, you're going to get 403 forbidden error and so on. So once like everything is done, on the right side you see this profile icon, right? So you have to click that profile icon, and there would be an option called as settings, and then you would see an option called as create new API token. So it would be like this. So you have to log into Kaggle. So verify your account with, like, let's say the phone number and the email address and all those stuff. And once that is done, you have this profile icon on top right corner. So click it, and then you would see a settings option. And once you go to the settings option, you would see an option to create new API token. So when you click that, that's going to give you a Kaggle.json file. So once you download that file to your local machine, you can open this files thing in Google Collaboratory, and there you would be having an option called as upload. So upload to session storage, and I have this file in my download section called as Kaggle.json. So you can just upload this, click OK here. Yeah, so our file has been uploaded. So this is basically a JSON file that contains key value pairs just like a dictionary, and this contains my Kaggle username and my secret key. So those two things are present. So if you want to look at this, right, you can just like first run this. So this is going to load this data into a dictionary called as Kaggle config. So if you want to look at it, just do print Kaggle config, but I don't want to display my username and key here. So I'm just like showing you what are all the keys that's present in this dictionary. So the two keys are username and key. So now we have to save this username and key in our environment variables. So for loading this JSON, we have used this JSON library, and for saving this in the environment variable, we are going to use this OS. So say os.environ Kaggle username. So this shouldn't change. We shouldn't change this Kaggle key and Kaggle username, because once we use the Kaggle API, this is where it's going to look for the username and key. So we say os.environ, that means create an environment variable called as Kaggle username and then Kaggle key. So create another environment variable called as Kaggle key, and just like give your username and key over here. So run this, and that's going to be saved in your environment variables. So the next thing is calling this Kaggle API. So come back to your dataset. So we have this 45 million song dataset. So go to this option. Okay, so it's not presented. So maybe like scroll towards the end. So we would have an option to download this from an Kaggle API. Okay. So again, this is like another method to get it from Kaggle, but we probably won't be doing that. So I'll go to this options, new collection, add to collection, download Kaggle. Okay, so here you can go to this download and just copy this part. So not Shirang, so the account name and the dataset details. Come back to your Google Colab environment, say this. So Kaggle datasets space download, and just like paste it. So this is what we have copied over here. You can just paste it. So previously there would be like this API that's kind of given here. Yeah, something like this. Okay, this is where it is. So these are like different methods, and you can like try any of these methods. Maybe if you want to do everything in Python library, you can use Kaggle, but if you want to use API, you can open this Kaggle CLI. So just copy this Kaggle datasets, download this account details and dataset details. So that's what we have basically like pasted here. So and then you just like run this, and this is going to download the dataset. So you can see like the download process happening, and this is going to be pretty quick. And this is like a better method because some dataset would be like so huge, it's like 10 GB, 15 GB, and so on. So it's not possible to download it and then upload it. So rather we directly pull this into Google Colab environment, and then we can just like work on it. So this is like a better way of doing this. So now if you open your files, you're going to see the dataset that you have downloaded. So I'm clicking this refresh, and you would see this Spotify million song dataset, which is a compressed zip file. So you can just do exclamatory mark, which is representing that we are going to run a Linux kind of command. So ls is going to list all the files. So it's going to say you have kaggle.json sample data and this as your dataset. So if you remember, we have imported this zip file in our importing dependency part. So from the zip file, I'm using the zip file function in order to extract all the contents of this dataset, Spotify million song dataset.zip. So read this file and extract all the content. So when I run this, this is going to do the extraction. And again, when you click on files, you would see like the datasets that's present. So copy the path. So go to this option and copy the path. So this is what you would get, content slash Spotify million song dataset.csv. So this is the CSV data that we need. And here we are saying df is equal to pd.read CSV, where we have imported pandas as pd, and that as read CSV functions is going to read a CSV data and put it in a pandas data frame. So run this. And now you have a variable called as df, which is a data frame and as like this particular data that we have just now seen. So we can just like do a bit of research on like an understanding of what this data set contains. So when I run this df.shape, it says that it has 57,650 rows and 4 columns. So df it would just give you the top 5 rows in that data frame. So we have artist details, song details, link for the song, and text. And again, you can just like go to this dataset card in order to understand like what it contains. Some datasets they have given like more detailed explanation, but this says that this is a Spotify million song dataset, and this dataset contains song names, artist names, links to the song, and lyrics. This dataset can be used for recommending songs, classifying, or clustering songs. So this is like the purpose. So basically, what we now need to understand like what are those individual columns are. So we have artist name, song name, lyrics. Sorry, so this is the text, which is the lyrics, and link is to the link of the song. So think about recommendation, right? So when we want to recommend a song to someone, we can recommend based on a song that's similar to what someone likes, and also based on, let's say, the artist and so on, right? So these are different methods. Let's say that we want to build a content based recommendation system, and now we are going to use only the lyrics of the song to recommend it. If you want, you can also build like an artist based like thing as well, but we can discuss everything. But the main aspect is like we don't need this link because we are not going to recommend a song based on a link, right? So later we can just like remove this link because this is not useful for our recommendation purpose. And then you can run this df.info to see like if there are any missing values. So we have this non-null thing. So here we say that there are like no missing values over here, and these are the columns that's present. Just some basic exploration, and we are seeing checking like if there are any explicit rows that are missed. Like as we see, like null says is null dot sum, it's going to calculate the sum of missing values. It says zeros, that means like we don't have any explicit missing values. Some things can be encoded, but as of now we don't see any explicit missing values. So that's the other thing. So I'll just like run this thing again, df info again, and df is null this. Okay, let me just remove the output so that it's clear that everything we do is like we see the output of like what we have ran. So let me run these things again. So we get df.shape as 57,650, df info, df sum, and so on. Df info again like details about the data types and like the missing values and so on. And now we can look at the top artist, right? Like, just to understand this, analyze this, right? So let's say we have 57,000 songs, and like, you know, overall the top artist present in this song. So for that, you can say df of artist. So this is going to access the artist column in this df in the data frame, and it's going to kind of like do a value count. So it counts like, let's say if Donna Summer is the artist, like how many times Donna Summer's songs has been appeared, because we just like count artists. So it means like in 191 rows we see the person Donna Summer, and we calculate this value count would give this number. Yet 10 is basically like I want only the top 10 artists. So I'm saying like dot 8. So there can be like thousands of artists, and it would count like how many times these 1,000 artists have appeared. So that's what this code is going to give us. This 810 is going to just give you the top 10 rows, so that like it's like kind of the top set that's present in this data set. Just for that particular analytical purpose, we have this. So it's just like prints you the top 10 artists to get an idea. And here we are creating a sample. This is again, you can just work with the entire data set, but the thing is it can be a time consuming process. So we are just like kind of experimenting this with only 10,000 songs. Again, if you want, you can change this number to 20,000 songs, and if the time is kind of not a problem, you can like include this entire data set itself. So we are creating a sample of 10,000. So it's going to randomly sample like 10,000 songs from this data frame, and we are dropping the link column as we don't need this for our recommendation purpose. Reset index drop is equal to true. So what this does is when you do this sample, so all the rows are going to be interchanged, and now the index are not the same. So we have 0 1 2 3 4, right? So all are now kind of in a jumbled and sampled way. So now we are just like dropping those rearranged indices, and then like resetting this so that you again would have this values as 0 1 2 3 and so on. So let me run this. And now if you kind of like analyze this data, so if I do a df.shape, and that's going to give you 10,000, and there are only 3 columns because we have removed the link column. So if I just print the df of it, it's going to give me the first 5 rows, and you see this 0 1 2 3, a new index, but the rows has been changed. So previously we were seeing this a b b a and this particular song and so on, and now it has been changed because we have sampled 10,000 songs from this, so the order is kind of changed now. So that's about it, right? So this is for that. Let me move this cell down. Okay, so far we have just like loaded the data set, just did some initial cleaning of removing the link, reset the index, and other stuff. Now we are going to kind of build a plot for this. So we have what we call as a word cloud. So I'll maybe first run this and explain you what this does so that it makes more sense. It is just to understand the words present in a data set. In this, right, so the data set is nothing but song lyrics which is present in the text column of your df. So we are going to understand the impact of words and what are all the words that are repeated a lot. So this is what a word cloud is, and it kind of displays like the words that are present most number of times. So here you can see the word love is present in a bold and larger way. That basically means that this particular word appears so many times in your entire data set. And let's say, and we have want and got and so on. So these are like other words, maybe the next words that have kind of appear like several times, not as many times as love, but those who have like appeared several times. And if you see, you have this art and so on. So this basically gives you an idea, just like visual representation of like what are all the important words and the words that have been like repeated several times. So how we are doing this is we have like these two cells that does this. So all lyrics is equal to join df text drop na. So if there are any missing values, again we won't have any missing values, but we are just like making sure if there are any missing values, drop this. And apart from this, join this text. So when you run this space dot this space is present in a string and we say dot join df text, it's going to join the text of all the rows. Like we have 10,000 rows, right? So it's going to join the text content, not the artist and song, because we are just only focused on the text. So it's going to uh, take all these 10,000 rows, 10,000 songs lyrics, and it's going to join them with some space. So that's what this basically means. So it's going to take all this df text and then just like join it with some space between them. So it's just a single larger string. So that's what this all lyrics is, which contains like all the lyrics of the song. And word cloud is where we are using this word cloud, which we have imported previously. So we have imported that from word cloud library. So yeah, from word cloud import word cloud, and then like we are kind of working on this. So next step is, yeah, word cloud with height, like basically the size of the plot, what's the background color. So we have set the background color to be white, generate, and how it should generate is based on the large string which contains all the lyrics, and just like putting it in a matplotlib uh, plot. So in a plot object, so plot figure what's the size, and just some configurations like do you need the axis, like what should be the title and so on. So this is how we can kind of print this word cloud. Again, this is just one single example of how you can analyze this words present in this dataset, but there are other analysis as well that you can try. But let's just keep those analytical parts simple, just like focus on how we can build this recommendation system. And the next part is like data pre-processing, and that we are mainly going to use the NLTK library, which is Natural Language Toolkit library. So from that, we are you kind of like download this NLTK, download punct tab, and stopwatch. So these are kind of like pre-trained tokenizer. So you can just like go to Google and search. So this is what it is. So NLTK, Natural Language Toolkit, punct is a module used for sentence tokenization. So basically tokenization is nothing but we, let's say we have like a song lyrics that has like 100 words. Now you need to separate each of these words. So here we are going to use a word tokenize. That means it's going to separate each of these words individually. So that's one way of tokenization. So similarly, you have like different methods of tokenization. So all those tokenizations are present in this punct module in the NLTK library. So we can just like download this with NLTK, download punct and punct tab, and so on. And then stopwatch is it's a different thing. I hope you are clear until this part. So now let's discuss about the stopwords. Stopwords are nothing but the words that is kind of some basic English words that kind of appear a lot of times in your data set in general conversations, but it doesn't have that much meaning to it, like individual unique meaning to this. If you just like look at it, right? So here we have the word called as O, and we may have word called as like the, is, are, and so on. Like these are like words that are like most common, but it doesn't have that much meaning. But those are what we call as the stopwords. The reason we are downloading the stopwords is like it gives you all the list of stopwords that's present, so that we can remove this stopwords from our dataset, because we don't want to uh, recommend the songs based on these stopwords, as they are not significant. We want to recommend based on the content, with only the significant words. So we will use the stop words in order to remove those from our database, from the dataset that we have. So these are the things that we are downloading from NLTK library. So this is something that you have to run once. So if you're running this in your local machine, you don't have to download this every time. So you only download this for the first time, and later it can use the one that has been already downloaded. So it's kind of like a one-time process. Stop words, we are creating a set stopwords.words English. So you can just access all the stop words that I've downloaded for this specific language and say that stopwords.words. So in this English stop words, basically get a list of all the English stop words, and we are putting it to a set because we know that set is going to make sure that the repeated object, the duplicates are removed, right? So a list can have duplicate values, but a set doesn't allow duplicate values. So when you put it through a set, it's going to remove like all the duplicate values. So your stop words English would give an array of stop words, and we are removing the duplicates using set, and we are storing this in the variable called as stop underscore words. So now we have a data cleaning function called as pre-processed text, and the input to this text is can be one song lyrics, right? Let's say that we are going to process all these rows individually, all the 10,000 rows individually. We have combined it just to build this word cloud, but we won't use this later, all lyrics. This is just for the plot. So but later we would just like handle all these rows separately. So let's see what we are doing here. So we have a function called pre-processed text, and it's going to do a bunch of things. So maybe I'll first run this, as this can take some time. So I'll run this and I'll explain this to you. Okay, so the first step is remove special characters and numbers. So we want to keep this as minimal as possible so that the data pre-processing can take like lesser time and we can just like build this system quickly. So we are trying to, again, special characters may not mean much in this context. So we can like remove those special characters and numbers. So for that, like we are using this specific code, and this is where we are going to use the RE library, which RE stands for regular expression. So we have text is equal to re.sub, and then take this R and mention this within double quotes. You don't have to change this. Basically what we are trying to do here is, if you are given a text, right, it can be, let's say, the first row that we have over here. You need to extract everything present in the alphabets A to Z, or it can also be uppercase letter. So it's you whatever allowed is like A to Z, and then A to Z uppercase letters. So only the alphabets are allowed. So that's about it. So and then we are like passing this text to extract only the text. So it basically, in other words, remove the special characters and numbers. So that is what it is. So you can use this cap symbol that's present in like 6 on your keyboard. So you can just do a shift plus 6, and that would just like print this cap thing. So A to Z and A to Z with like lowercase a z and uppercase low like A and Z, and then convert to lowercase. So again, just to make sure that everything is present in a proper simple format. So we are just like treating all the letters in the same way. So we are making sure that all the alphabets are present in lowercase letters. So now all the uppercase letters would be transformed there. So these are the first two processes that we are doing. First is like remove the special characters and numbers, and then you can convert all the alphabets into lowercase letters. And the next step is tokenization. As I said earlier, it's like how we are going to break down your words so that we can convert these words into meaningful numbers that the system can understand, the algorithm can understand. So for that purpose, we are using word tokenize, which we have already imported, and we are kind of creating tokenization for each of this song lyrics, like each of this row data. So we are creating something called as tokens, and creating a list called as word for word in tokens if word not in stop words. Basically what it does is it takes this particular lyric. So let's say that there are 10 words in this particular lyrics. So those 10 words are passed to this pre-process function. So in those 10 words, we just make sure that we have only the alphabets, all the numbers and special characters are removed. And in the next step, for this one string, right, the one string that contain 10 words, we convert all it into lowercase letters. And now we would separate this into individual words using word tokenize. So now you have individual words. This is what is something that you would have like words like, let's say, love, and then you have words like art and so on. So you have like a list of words like this, let's say the is and so on. So it would look kind of like this after the word tokenization has been performed, let's say in the form of a list. Now what we are doing is we are taking only the words. So this would be like, previously all this would have been in the same line without any commas. in the single word. So later this word tokenized, it would be kind of converted into like individual, let's say, elements of a list. Now from this we have to filter out the stop words. So let's say the and is are stop words which doesn't have that much meaning. So what we do is we iterate over this tokens. Tokens is nothing but this list that we have created over here. So we iterate over that list, and if that word is not present in this stop words, then we consider this word. So basically we in this for loop, right? So we have a list comprehension where we are creating a list based on a for loop. And how we are doing this is when this for loop runs for the first time, we take the first word. So word for the first time, the word would be this value love, and we check if this love is not present in stop word. That means this is not a stop word, so you put that in a list. And again do this for art, and we check it, and let's say art is not also present in the stop words, we kind of add that to this tokens list now. So we do the same thing, but the and is are present in stop words, so this condition is not satisfied, so we just keep that. So after this should kind of look something like this: love and that. So this is how it would look like after like removing the stop word. So this is this process. So we create a word tokenization, and then we make sure that we only have the words that are not stop words, because only those words have meaning. Stop words doesn't have that much meaning. So that's about it. And then finally we are returning it, just like we have joined all the lyrics, right? So now what I would do is join the words that we had. So this would just like give you a string that is something like love space arts or love space art. So you're going to join it with the space that's mentioned here. So first we take a single song's lyrics, remove the special characters and numbers, convert it into lowercase letters, and then convert it into individual words using the word tokenize, remove the stop words, and then just like join like all those important words that you have captured. So this would be the input, sorry, this would be the output when you send a input like this, like to lyrics. So now we are going to do this for all the individual data frame rows. So let me remove this so that it's not creating confusion. Okay, so this is the function. So as I said, we are going to iteratively do this for all the data frame columns. So for that, we are using this apply. So I'm accessing the same data frame that we previously had, which is this df. So to this df, we are creating a new column called as cleaned text. So what this cleaned text contains is df of text dot apply preprocessed text. So what this dot apply preprocessed text apply kind of does is, as you can see, to this apply we are sending a function as the parameters, a function as the value to this apply function. So what it does is this would apply the function called as preprocessed text to all the rows that as this like tf text. So that's what happens. So it takes like all those individual rows and does the processing, and finally you have a data frame column called as clean text, and that's going to have this process text. So if you now say this df of cleaned text or df of yet, right? So that's going to give you the process data. So it would have a new column called as clean text. As you can see, it only like has like the lowercase letters. As you can see, it doesn't have any it doesn't have any special characters, and all the stop words have been removed and the data has been processed. So you can see the difference between this and the cleaned text. So this is the processing that we are currently doing. Okay, so once we do this, next is a very critical aspect, which is converting these words into numbers. As we know that the computer systems doesn't understand words or letters, it understands only numbers, right? So for that we are using a vectorization method called as TF-IDF vectorizer. So TF-IDF stands for term frequency and inverse document frequency, and it basically gives like ranking on like the importance ranking, right? But there are two things: one is term frequency and there is also an inverse frequency. And we are trying to find max features of 5000. That means in this entire data set, right, in this entire clean text, all this entire text that's present, the 10,000 row values of all this 10,000 song lyrics, it tries to find the max features of 5000. That means it tries to find the top important 5000 words. So that's what it does. And how it does, it's a very interesting thing, because it's again does two things, which is term frequency and inverse frequency. So what does term frequency means is, let's say if there is a word called as love that present several times in a particular song, then that word is important for that song, and that word is important in this data set's context. But let's say there is a word called as try that's present several times in several songs. That means it doesn't have that much importance because it doesn't create a difference, right? So that's the key aspect here. So that is what we call as inverse document frequency, where if it is present throughout the document, throughout the data, then the importance kind of reduces, whereas the importance increases if a particular word is repeated in a document several times, like say like the word love and so on. So that's how it tries to find. Again, the word I'm just giving you as an example, but those words could be anything. So in that way, it tries to find the top 5,000 vocabulary, top 5,000 words, the important words, and then we would kind of like convert it, give let's say an importance score, and you kind of convert it into a vector. So now for each of these lyrics are represented as vectors with those importance, like each word, right, would, we would say that if it's present in the top 5,000 words, so that's how it can be represented. So it's like you take a song lyrics, and there can be 100 words in a song, and we try to find the importance of this each of these songs, and now you have this importance score as a numerical metric. So this numerical metric can later be used to process this and to understand like which songs are like related to which song, or not related, but which songs are like similar to other songs. So that's the next step. So this vectorization with TF-IDF would try to find those important words, important top 5,000 thing, and again this is configurable. You can give other numbers and try it based on like how the output is. And later we are creating a matrix called as cosine similarity matrix. So here, the reason we are using this cosine similarity is like now all you have is like the individual vectors. So each of these lyrics, each of this one row would represent a vector. Now we have to compare each of this vector to other vectors and find like what's their similarity. And in order to do that, we can represent these lyrics in the form of vectors, and then like that's what we have done in this TF-IDF vectorizer part. So if I just search for cosine similarity of two vectors, right, so when there are like two vectors, when you find similarity, that means like when they are closer to each other, that means like they are similar. So something like this, right? So if two songs are similar, let's say that we have two songs A and B, and if we represent it in vector space, if A and B are closer to each other, that means like they are similar, and if they are unrelated, there would be a larger difference like between them, and all completely opposite would have like very large kind of 180-degree difference between them. So this is like kind of what we call as kind of a cosine similarity. And again, we have this all this formula. Again, we don't have to go detailing into the formula, but this is the overall eye level overview of this. So you take each of these songs as vectors. So here A can represent one song and B can represent one song, and you try to see like what's the similarity score, or like what's the distance between them. If the distance between these two is same, if the difference is smaller, that means they are similar. If the difference is large, that means they are like kind of unrelated, and so on. So that's how we are going to calculate the distance between the two vectors, or in other words, we are going to find the similarity between the two songs, and we are going to present it to the user. So for that, we are going to use something called as cosine similarity, and we are passing this TF-IDF matrix, which is all this data being converted into feature vectors, and then you just like compare like these two things, just like we are comparing the same thing. So what's happening here is in this 10,000 songs, right? Let's say totally we have 10,000 songs. This is the first song. This song is again compared to all the other 10,000 songs. Just think about this. So I have this first song. Let me put it over here. So this gets compared to, let's say, DF of cleaned text, all the other songs along with the same song as well. So you have 10,000 rows, right? So you basically compare this song's lyrics, again not the exact words but the converted vectors, the TF-IDF vectors. So you compare this vector with all the other vectors that we have along with this same vector, which we can later ignore. I'll come back to this later, but think about this. So when you run this cosine similarity TF-IDF matrix and TF-IDF matrix, it's going to take all this individual song and it's going to compare it with all the songs present in the database. Again, this would do this for the first song, and then it would have like again 10,000 score, something like this song is related to this song like this much percentage, this is related to this like this much percentage, and so on. So each song would get a score compared to all the every other song that's present over there. So similarly you do this. So you first compare the song 0 with all the songs, and then you compare song 1 with all the songs, and so on. So this process happens, and then this process goes. Let me delete this. And all this scores details are present in this matrix called as cosine similarity, and this is what we are going to use. Now when the user, let's say, selects this particular song called as for the first time, we look at this matrix, this cosine similarity matrix, and see like out of this 10,000 song, which song had the highest similarity score, and that's how we are going to present it. So that is basically the entire idea of this. So you have the lyrics of the song, as this is a content based recommendation system, so you are going to convert it into vectors and create like cosine similarity matrix that tells you like what are all the similar songs to this based on the scores that we generate using cosine similarity. And now we finally have this is kind of the predictive functions which is going to recommend you songs. So we have a function called as recommend songs, and this is going to take song name as input, this cosine similarity matrix as input, df the original df, so that it just gives you the idea of the song, so that later we can match it in the data frame and see like what's the corresponding song. I'll explain that. And finally, top n, again, how many songs you want to recommend. You can recommend 5, 10, 15, any number of songs. So here let's say that we want to recommend 5 songs, so we say that top n is equal to 5. So IDX stands for index song str dot lower song name index. So what we are trying to do is the user is going to not give the index but the song name as the input. So let's say Christmas memories, right? So that's basically coming from this column called as song. So what we do is once the user gives this song name, we look at this original df data frame, and let's say for the first time is the song name, so we look at this index 2 and try to find like what is the calculated similarity score and all this stuff. So we look at this index. If a particular song is not present in the df, let's say the user is giving a song that's not present in a database, in that case we are going to say that song not found in the dataset, because currently we are not handling that. We are handling this or recommending songs for only the songs present in our dataset. But again, this can be scaled later. I'll talk about this a bit later, but yeah, for now we are going to recommend the songs that's present in our database. So in order to have that check to make sure that if a song is not present in our dataset, we are going to say that song not found here. So after that, you give this index, because this cosine similarity would have all the details on songs as well as the corresponding index. You take a particular song. Let's say that the user is giving this song called as for the first time. Now you find the index which is 2. You put that index to this cosine similarity, and then create a list that gives you the similarity score. So like it would contain like 10,000 values, right? So if you take this for the first time song, let's say it would have values like the first song would have got a similarity score of let's say 5 and the second would have got a similarity score of 0. Let's say 4 and so on. So the values would be between 0 and 1. So let's say this is the value, and for the first time this is the exact song, so it's going to match it as 1, right? So this is what you would get. Let's say this is matched like 8 0 and this is matched like 0.3 or 0.1, which means like it's not that much related and so on. So this is for the first 5 songs. So similarly you have 10,000 values for this index that the user has given for this particular song. Now we find the similarity score as well as the index. So let's say the index is 0. 0 basically means it's 0th song similarity score. This would have like 2 comma, this would have 3 comma and so on. So all this means is like this represents the song number, the index number, and this is the similarity score. That's what enumerate does. So enumerate give the similarity score, but also it kind of gives you the index values 0 1 2 3, like all those values are given. So we kind of take those index as well as similarity score and we sort it based on the index. So you take this, sort the similarity score, x of 1 is basically like kind of order this based on the similarity score. So the similarity score comes as a second value. So that's why we are using x of 1. That means reorder this list based on the second value, which is the similarity score. So this would now kind of look something like this. So 2 comma 1, if the index here is like let's say 3 comma 0.8.0 and this is like 4 comma 0.1.0. So all this would be kind of now changed to 2 comma 1. The next important song is the similar song is 3, and let's say the next one is 0 0. So all these are ordered based on the second value, which is the similarity score, and then you would put this let's say 0.40 next, and finally you would have this thing at kind of like last part. So this is what you would get, right? So after like sorting it based on the second number, so it's descending order of the similarity score. So that's what we are doing here. So we are sorting the similarity score based on the second value using this lambda function. Reverse is equal to true. That means we are sorting this in descending order, because higher the value, that means more similar the song is. Now we know that we shouldn't consider this first value because it's exactly that same song. So if someone says that I like this blank space song, we cannot recommend like listen to blank space again. So we just like remove the first recommendation, which is exactly that song. So for that, we are using this similarity score 1 colon top n plus 1. That means include everything except the zeroth index, right? So this would be my first recommendation, but don't include that. So we have a list and start from 1. So it's like kind of we are slicing this. So let's say this is the list that we have, and we are slicing and getting only these things like separately. So now these are the 4 recommendations. So similarly to do that for like the top 5 recommendation, but like that's the whole process. And finally you would have all this index like original index 3, 0, 1 and 4. Now we go back to our original data frame, get the 3, 4, like all those indexes, and get the artist and get the song and recommend this. So this is how it's going to work. I'll just remove this thing. Now let's see how this entire thing works. I'll again go through this again. Okay, cosine similarity, we didn't run this. Got it. Okay, let's run this as well. And that's how it works. So first we find the index of the song by kind of putting this song words to this data frame and checking the index. If it's not present in the data frame, if that song not present, say it's not found. If it's present, then look at the similarity score, reorder this based on the similarity score, and then return all the indexes except that same song index, and then put those indexes back to this data frame, find the artist name and the song name. So this is how this entire thing works. This may seem a bit kind of uh, you know confusing a bit, but you can just like watch this part of the video again, so that would make more sense, and even you can like code this by yourself like line by line, and that would give you like a better idea. So let's say that now we want to test this. I'm printing like the song number 2, which is for the first time. So you can pass that thing as the input for this recommend songs. All these are like optional parameters. You don't have to give this. You can only give the song name. If you want, you can also give top n is equal to some number, so that's going to give like, let's say 5, 6, or any number of recommendations that you have. So you create a variable called as recommendation. You call this function called recommend songs and pass the song name and just run this. So this is going to give you the artist song name. So this data, so how this is first comes is like first it looks at this song, which is Christmas. Okay, this is for Christmas memories, but I have to do this for the first time. Let's say we have to do this for this one. Now it goes back and looks at this songs index, which is 2. Go back to the cosine similarity, find the similarity songs, and rearrange all the important songs. Now it would have only the index 7780, 4788, 2900, and this is the step where it passes the index over here and locate the artist name and song, and it's going to return this. So this is how this entire thing works. So the key aspects here are like one is like the data pre-processing step where we read the data set, process this data set to TF-IDF vectorizer to convert it into numbers. We cleaned that by removing the punctuations, the special characters and the numbers and so on. So once we done that, we have created TF-IDF vectorizers thing, so that those are converted into vectors. And then with the vectors, you are finding the similarity score using cosine similarity, and then we are just like recommending songs. So this is kind of like the brain of the application, and this is how it kind of works. The next step is we are going to combine all these things to proper functions and create a Streamlit app. So this is the code for that, and I'll give this notebook file as well as like the Streamlit app code, which is to create this user interface, right? So I'll give all this codes in a GitHub repository that you can just clone and you can just like work on it. So let's understand about this. So this app mainly contains like whatever we have seen, nothing different, just like whatever we have seen, but just in like proper functions. I'll just like maybe delete these things. I'll show you how these files are getting created, but for now let me delete this. Okay, this is being used. Okay, okay, so we have main.py file, preprocess.py file, and then we have recommend.py. So we have 3 Python files. We have the dataset, which is 45 million song data.csv, and then you have a requirements.txt that has like all the libraries you need. So you have Streamlit, Pandas, scikit-learn, NLTK, and Joblib. So these are the libraries that we need. So now let's understand this code. So we have a Streamlit app code. It says import Streamlit for recommend df recommend songs. Recommend is like the same recommend functions that we have created, just some minor changes. You can go through it. Maybe I'll first start with the pre-process step. Let's come back to the Streamlit code later, but let's go part by part. So first thing is, let's say you have a requirements.txt that has like all these libraries, and then you have pre-process. What this pre-process does is what we have exactly done in the previous step. So you read this CSV data, sample it to 10,000 rows, drop the link column, process the text by removing like all those things, create tokens and so on, create your TF-IDF matrix and like all these aspects, cosine similarity score, everything, just what we have done. But all these things are currently now present in a proper script. So that's the purpose. So when you run this preprocess.py, it's going to read this Spotify million dataset, and it's going to create these files called as df cleaned pickle, tf matrix pickle, cosine similarity, and so on. So these are the things that you need for your recommend songs function, right? So we are saving this cosine similarity as a pickle file, df as pickle file, and then the other thing is your data frame itself, like the data frame, TF-IDF matrix, and the cosine similarity. So we are like kind of like saving all these as files. This is what happens here. And the next step is recommend.py. So how this works is again the same thing. You give a song name and top n is equal to 5, and then you load this data frame, cosine similarity, and so on. The reason is you don't want to create this data frame, create this cosine similarity every time, because it's going to take some time, right? As you have seen, like executing all the scripts takes some time. So we kind of do this as a batch process where we complete all these things in kind of like before we start the application, before we start the user interface. So you kind of do this all this calculation, convert it into vectors, find the similarity scores, and then save everything as like files in the pre-process script. Later load it using joblib. Just like pickle, we can use joblib, which is like much optimized for like scikit-learn objects and models and so on. So in this pre-process, you are saving this TF-IDF matrix, cosine similarity, and saving it as pickle files. And this recommend thing, you are just like loading it back and then passing it to the recommend song function, and everything works just like the same. You just create a final data frame with the artist and song details. Just like instead of having the serial numbers as like the index numbers, we are just going to replace it with like 1 2 3 4 and 5. So that's like the other additional two lines of code, but everything other things are like the same. And other standard thing that we have done is like we have included a log file. So when pre-process runs, it kind of stores all the logs in a .log file, so that if there are any errors, if something is going wrong, we can monitor like all the stock logs. The other reason for doing this is to make sure that everything is in a proper standard code. So the only difference is like having like all those log files and like exception blocks. Other things are like pretty same, so you can just like go through this and it's pretty self-explanatory. Similarly, for pre-process also, we have like the similar logs and so on. So pre-process logs would be saved in pre-process logs, and recommend logs would be saved in recommend logs. So when you run these scripts, right, so the two files would be like created here, and then like uh, we could just like get the entire output, which is like saving the files, the df cleaned, cosine similarity, all those files. And once everything is done, we have the main.py file where this is the Streamlit app. So we are importing Streamlit. Recommend function is imported because now we are going to recommend songs to the user. Set page config. So this is just to give a title icon and a page icon, page name, and so on. I'll explain all these things once I start the application. But yeah, the thing is like, maybe I can just start this and show you, but before that we need to do one thing. Okay, I'll explain about this Streamlit main.py later. Now let's first start the application. So for you cannot start this main.py first, but first you have to run this pre-process, because we need the process data, right? So we need that cosine similarity thing, we need the data frame file and so on. So for that you need to run this pre-process. So what you do is, there is also a file called as startapp.txt. So you can just open this. So clone this repository to GitHub. You can download all these files, open it in PyCharm. So you would have the similar structure. So you have src, a virtual environment that has like all these libraries. So if you don't know, there are videos that I made to how to create this virtual environment. You can watch that. And then we have the git ignore all the GitHub files requirements.txt. So to start this, first run, just follow like whatever code is present over here. So open your terminal. So this is currently in your virtual environment. So that would look something like this, venv. So if it's not activated, you wouldn't see this venv there. So it would look something like this. PowerShell would be there and you would see this. So in order to activate this, you need to mention the venv name slash scripts slash activate. So now it has been like activated. Let me create a new terminal. Okay, so now we are in the project directory, which is this music recommendation app Python, the project directory. So first, this folder has a file called as requirements.txt. So run this pip install -r requirements.txt. So that's going to install all the libraries that we have mentioned over here. So I'm running this on Python 3.12. So yeah, so if you are running older versions, you may get some errors. So you can just like alter the library versions, or you can remove the library versions. So that should solve the error. So then I'll clear this. The next step is we need to navigate to SRC folders, because this folder only, the source code folder only contains like the pre-process and the main.py file. So recommend is not kind of executed separately, because this recommend.py file is later imported in the Streamlit app over here. So we don't have to run this, but first we need to run this pre-process and then run this main.py, which is the Streamlit app. So I'll come back here, start app.txt. So once I'm in cd src, right? So cd would navigate you to the src folder, and this src folder contains like preprocess, recommend, main, and so on. So now say python space preprocess.py. So this is going to run this preprocess, and you're going to see all the logs, and you will also see like a log file created. So all these are like logs that we have created: dataset, loaded, and sample. This is basically coming from this part. So we have this loader like logging info starting pre-processing, which is present over here, and then dataset loaded and so on. So dataset loaded is coming from here and so on. So finally it would just say that pre-processing complete. So it says pre-processing complete, and all these are saved in a log file as well. So you see, so all the info and everything is like starting a pre-processing, which comes from here. So all these logs are saved just to track the process. So I'll close this, and we now have created kind of these files: TF-IDF matrix, cosine similarity pickle, and DF clean pickle. So these are the files that we have created. Now the next step is, once you run this pd python preprocess, run this streamlit run main.py, and then just like run this. This is going to start your Streamlit application. Again, make sure that you are in the src directory, so then only it would work. Now let's come back over here. Right, so now we have this instant music recommender. So you see this headphones symbol and music recommender and music symbol, right? So that's basically coming from this streamlit.page config. So we have typed in this music recommender and the music symbol. So that's what is displayed here. And the page icon is a headphone emoji, which is kind of displayed here, and layout is center. So you see that everything is confined to the center part. So that's for this layout. So you create a title called as instant music recommender, which is displayed here. And again, the reason we call this instant is because we have pre-processed everything beforehand, and when a user selects a song, the recommendation should be like pretty quick, because we are not doing the pre-processing in the real time, as we have like all the data processed. Song list is like, now you take like unique list of all the songs that are present in this df. Df is basically coming from this recommend py, where we load this data frame and we kind of like return it. So we can like get this df, like not the recommended songs df but the original df. So from this recommend.py, we are returning this data frame to this main streamlit app. So that's going to look at this song. This is just nothing but you have this original data set, right? So from this we are finding like unique song names and putting it to this list, to this drop down. So that's what this part is. So we are creating a list, we are sorting like all the songs, dropping if there are any missing values, just taking the unique values, and creating a drop down select box using this st.select box. So we are saying that select a song. So this st.select box is the drop down you are seeing, and above that there is a tag, right? So this tag is coming from this parameter that we have, and the input is song list, the song list that we got from the data frame. And then we are creating a button called as recommend similar songs, which is this button, and once you click this, there is going to be a loader. You don't see this loader because the process is happening pretty quickly, but if the process is slower, you will see a loader that would say that would give a loading symbol, and it would say like finding similar song. And then in this recommendation, we are calling this recommend songs function, the functions that we have created, and then we are passing the song that the user has selected. So if the user has selected did I do, so that would kind of get passed to this recommend song function, and then we would return the top 5 recommendations for them, and then just like display it on a table. Say that if it's not present, say sorry, song not found. If the output is none, because here we are returning a none over here. If there is a successful response, then you get a data frame table like this result df. Just put it through st.table, which is in function to display the table object, the data frame objects. That's the process. So now how this entire thing works is, so we have the page title, icon, and everything is there. So let's say this user is selecting this particular song and clicking on recommend similar songs. So it would say top similar songs or the serial number that we have reset, the artist and song details. So again, they can just like choose a different song and then we would like see this. So this is how this entire thing works. So first we process this song. First, like in the collab environment, we kind of figured out like how to build this recommendation system and then just like put everything through proper scripts. So here we have three scripts, which is like the pre-process script, which has to run before the Streamlit app so that it creates this cosine similarity, DF cleaned and everything, the TF-IDF matrix. And then we call this recommend.py from the Streamlit app. Once the user clicks on the recommend similar songs button, at that time only we call this recommend songs, which comes from this recommend Python script, and then just like follow what we have already discussed. So look at the cosine similarity matrix, find the top 5 songs, and then just like display it to the user. So this is how you can kind of build the system in a more standard way. It's not like writing something and just like showing all the output in collab. So that's not what we have done. So we have kind of first built this base code for our application, and then we have added kind of like proper script to executed it, added like proper logging levels and so on, and then we have started it. And again, to start this application, just clone this repository, install the libraries and follow these commands, and that would start the application for you. Or if not, you can just like follow this video, do exactly what I have done, and you would get the output like as it is. And you wouldn't see this cosine similarity pickle files, like all the ones that are displayed in orange color. You wouldn't see this because all these files would be created to you in runtime. So when you run all these steps, like all these files would be created. So you won't see this, so don't worry about that. So these will be created like once you run this preprocess.py. So this is how we can build this kind of music recommendation systems and other thing. So the one thing that I mentioned that I would recommend is like, what if the user kind of types in a song that's not present in this dataset? So this code won't work for that because we are kind of focused on only the dataset that we have, because we are calculating the similarities beforehand. If something is like that, right, what you have to do is follow the same process. You have to kind of somehow find the lyrics using some external APIs. Let's say the user is kind of giving a song like shape of you, so we can use some external APIs in Python and some external APIs that would give you the lyrics. So put that lyrics through this vectorization functions, and for that lyrics again calculate the cosine similarity for all the other songs, and in real time you can just like find like what are all the songs that's similar to it. It's just like we have done everything beforehand, but for let's say the song that's not present, you can just write a custom script that's going to pull the lyrics from the internet and then just like do all these processes again, and then it's going to recommend it. It's a bit tricky, but it's like kind of a good exercise that you can try. But yeah, that is all that I wanted to discuss today, and I hope that this is useful to you. So please practice this code, and I'll give you both this notebook file as well as this all this Python and Streamlit script in GitHub, so you can just download it from there or directly clone it to PyCharm and you can work on it. So that is all from my side for today, and I'll see you in the next upload. Thanks for watching.